In this video, we will discuss three advanced features of VisSim Compound Blocks: Enable Execution, Local Time Step, and the Create button for Contained Compound Block Dialogs option. The Enabled Execution feature of a compound block allows you to control when, during the simulation, the compound block is executed. When the Enabled Execution option is checked, a round red-colored input pin is added to the compound block. This pin expects to receive a Boolean input. When the input is 1, the compound block executes. When the input is 0, the compound block does not execute. Its output is held constant at the value it reached during its last execution. To illustrate how the Enable Execution feature operates, we'll construct a compound block that counts time steps. From the Block's Time Delay menu, select and place a unit delay block. From the Block's Signal Producer menu, select and place a constant block and connect it to the Boolean input of the unit delay. From the Block's Arithmetic menu, select and place a summing junction. From the Block's Annotation menu, select and place a wire positioner. Control-Shift to copy the constant block and connect the summing junction. Encapsulate the logic in a compound block named pulse counter. Add one output pin for the pulse count. Navigate into the pulse counter compound block and connect the output pin to the unit delay input. From the Block's Signal Consumer menu, add and connect a plot to the output pin. Under System, System Properties Range, set the time step equal to 0.01 seconds and end equal to 1 second. Click Go to simulate the model. Since the time step was set to 0.01 seconds and the end time to 1 second, the pulse count increases from 0 to 101. Now we'll modify the pulse counter compound block to only count pulses from time greater than 0.25 to 0.5 seconds and from time greater than 0.75 to 1 second. Right button on the compound block and check Enabled Execution. From the Block's Signal Producer menu, select and place a square wave block and connect it to the red circular Enable pin. Right-click on the square wave and set the frequency value to 2 Hz. We'll plot both the square wave signal and the pulse count in a plot block with the subplot count set to 2. Click Go to simulate the model. The Boolean square wave signal is shown in the upper plot in red. The pulse count signal is shown in the lower plot in blue. Since the compound block was disabled from time equals 0 to 0.25, it does not execute and the pulse count equals 0. From the time equal 0.25 to 0.5, the compound block executes and counts 25 pulses. From the time equal to 0.5 to 0.75, the compound block does not execute and the pulse count is held constant at 25, and from the time equal to 0.75 to 1, the compound block executes and counts 25 additional pulses for a total of 50. The local time step feature of a compound block allows you to specify the update time that the compound block is to be executed. Using our pulse counter example, let's use the local time step to see the effect it has on the pulse count value. Control-Shift left mouse to copy the pulse counter compound block. Control-right button on the compound block copy. Check Local Time Step, enter 0.1 seconds, click OK. Notice that the compound block turns to a light green color with a diagonal line pattern to signify it is operating under local time step control. Click Go to simulate the model. Observe the red compound block pulse count increases to 101 as expected. The local time step compound block pulse count is shown in blue. Since the local time step was set to 0.1, the block counts once every 0.1 seconds and achieves a final value of 10 pulse counts as shown. The Create buttons for Contained Compound Dialogs compound block option is a feature that provides a single window in the top-level compound block of a two-level compound block model to access all dialog constants. The dialog window consists of buttons with the names set to each of the second-level compound block names. Right-clicking on a button brings up the dialog constants for that individual second-level compound block. You create the button dialog window by checking both Create Dialog from Contained Dialog Constants and Create Buttons for Contained Compound Dialogs for the top-level compound block. And then for each second-level compound block, check Create Dialog from Contained Dialog Constants.